All right, so let's consider the following problem. We have K books, and we'd like to place them on in shelves. I've given an example right here. So we imagine that these are our 4 books. We have 3 shelves, so K is 4, N is 3. And we're going to see how many ways can we stick them on these shelves. So when I say stick them on, we're going to stick them all the way on the left-hand side. And all that really matters is the order of each collection of books on each shelf. So here, 1 is on shelf number 1, 3 followed by 2 on shelf number 2, and 4 on shelf number 3. And we'd like to count how many ways can you arrange these in general for a given K and N. Okay, so now for K books and in shelves, the first thing to observe is first put the first book down. How many ways are there to do it? There are in shelves, so there's in ways to place that book. And now the main observation is that every time you place a book down, the number of places that you can put a new book goes up by 1. So for example, the first time we place a book down, we have all these in different shelves. Let's say I place book number 1 right here. And now I say, how many places can I place book number 2? Well, there are still in shelves, except the shelf that I placed book 1 in, I have a choice. I can either be to the right or to the left of book number 1. So that old thing that used to be 1 single choice is now 2 choices, and the number of choices in total goes up by 1. So like in choices for the first book, in plus 1 choices for the second book, and then for the third book, let's say we place book number 2 over here for the third book, I can go to the right or left of book 1, right or left of book 2. Now there's 2 new possibilities over what we had originally. So we get n plus 2, etc. So this is for 1 book, for 2 books, for 3 books. You keep doing this, and once you get to the kth book, so this is 1 less than the thing over here, that's n plus k minus 1. The product of all those things is the number of ways of placing all the books. And so therefore, you could write this if you wanted to as n plus k minus 1 factorial. That would go all the way down to 1. We want to stop it at n. So once we get to n, we're done, and we want to cancel off the rest, which start at n minus 1. So it's n plus k minus 1 factorial over n minus 1 factorial. That's the number of ways of placing those books. Let's now consider a variation of this problem where we're forced to put at least 1 book on every shelf. So I'm going to keep this up for reference, but this time we're going to say we have K books in shelves and at least 1 book on each shelf. So how can we do this? One way to solve this problem is to first decide on which book is going to go on the left of each shelf. So you first take in of those books and just assign them to these slots, and then you just keep them there and put the other books in some, then say, how many ways can I place the other books on some other shelves? So let's do, first off, how many ways can I put exactly 1 book on each shelf? So, well, for the first shelf, there's K possibilities because there's K books. So there's K choices for the first shelf. For the second shelf, I've already used 1 of my books, so I have K minus 1 possibilities for shelf number 2. For the third shelf, I have K minus 2 possibilities, etc. Once I get down to the nth shelf, I have K minus 1 less than n, K minus n minus 1. Okay. Or, said another way, for the first book, so K minus 1, all the way down to K minus n plus 1. And you can write that nicely as K factorial divided by, and I'm canceling stuff after that, so K minus n factorial. Okay. So now that's just the number of ways of placing 1 book on each shelf, but now I have to place the rest of the books. Well, that's actually a problem we've already done. Once you've placed these books on the first row, on the first column of each shelf, then I have K minus n books left, and I'm going to simply distribute them onto the n shelves. And I want to say, how many ways can I do that? Well, we actually already did that problem, but we have to now say, instead of K books, we have K minus n books onto the n shelves. So the number of ways of doing the rest of those things, we can just work it out, is going to be, so what is that? That's going to be, so here the old k is now k minus n. So I have n, and the n is just n still, right? So we have, so I'm just going to copy that formula, n plus, and instead of k, it's k minus n minus 1, all that factorial, divided by n minus 1 factorial. And this top, of course, n plus k minus n minus 1, well, that whole thing is just k minus 1 factorial divided by n minus 1 factorial. And so altogether, what do we get? We get, the number of ways of placing the first book times the number of ways of placing all of the rest of the books. Let's just multiply those two things together and see what it looks like, because it'll look nice, right? And why else would we do it if it didn't look nice? We're going to do it. So what does it look like? It's k factorial divided by k minus n, you can still see that, good, factorial, and then times this, k minus 1 factorial divided by n minus 1 factorial. But look, if you add n minus 1 and k minus n, those n's cancel, you get k minus 1. So these three guys group together to give us k factorial times k minus 1, choose n minus 1. Lovely.